Okay, so today's topic, lecture number 17. We are getting close to our the end of the lecture anyway. We do have a few topics to cover, namely 18 and 19. And then lastly, demonstration of Microsoft project. So today's topic is about project time cost trade-off. And in bracket, I put a few terminology. Let's take a look at the videos so that we can relate to this topic. Okay, I'm not really sure whether you can hear and see the short video clip or not, but there are a lot in the YouTube, normally from China, that they did a fantastic high-rise building construction in a very short period of time. So the one that you saw is basically the time slab of about 15 weeks of how many story? Maybe 20 story of hotel building. Okay, the question is that if, for instance, if we are going to construct those kind of thing in Malaysia or in whatever country that you are, it might take a few years anyway, not including the extension of time, delays, etc., etc. I would say normally, easily you can go for 2 years or maybe 3 years. Okay, that is a normal practice. But the question is that if we can compress or we can shorten the construction period to even perhaps 2 weeks is basically the construction, the installation period. But of course, the preparation, the fabrication of those what we call precast concrete, panel, etc., etc., might take a little bit longer than 2 weeks, for instance. But overall, it is much shorter than the normal construction. So if we compress the project from the normal duration to certain allowable duration, what would happen to the cost? The time we know it is going to be compressed, what happened to the cost of the project? Can the cost of the project increase or decrease or remain the same? That is the issue. The overall thinking would be the cost would basically increase to a certain extent, okay? Because the analogy is that whatever things that you want faster than normally it involve a cost increase. Everybody basically experience food delivery. For instance, food delivery or even Grab, e-hailing Grab. If you want it a little bit faster, you need to add more money, isn't it? That is the same concept that we are going to relate to the construction project. Project time cost trade-off. Maybe this terminology you are not familiar, okay? Project time cost trade-off. But how about if we mention it in different terminology? Project expediting. Expediting meaning to say we expedite the project, we make it faster. Or we can also say project compression. We compress. What are the things that we are going to compress? We compress the overall project duration. Or another term, project crashing. Well, crashing in general term might sounds bad things, but when we use in scheduling, it simply refers to we crash certain task duration so that at the end of the day, we crash meaning to say we make it short. At the end of the day, the overall project duration could basically decrease as well. That is what project crashing refer to. So all these terms, project crashing, project compression, and project expediting, and project time cost trade-off refer to uh, the same, the same things. Okay, the same thing meaning to say when we decrease the project time, the cost will be affected. The cost will be affected, and that is when the trade-off is all about. So when we want something, we need to sacrifice something. That is what trade-off simply mean. But in some of the layman term, we are going to use this thing a lot: project crashing, project compression, and project expediting. So when you hear this terminology, basically it is related to this issue. Issue meaning to say, what if we reduce the original plan of the project completion and we reduce, what would happen to the cost of the project? Okay, that is the thing. I already given you this short formula last 2 weeks when I start telling about resource management. Okay, I mentioned about the word V, and then I mentioned about the word C, and I mentioned about the word P. V refer to value, project value or contract value. This is the amount that you are going to sign the deal with the client anyway. Okay, so this is what client's liability to pay the contractors. And contractor will basically construct whatever building wanted by the client. And of course, in order to construct, contractor need to pay here and there. So there is a total construction cost that contractor have to bear. And that total construction cost, in short, we simply call C. There is a composition of C, direct cost and indirect cost. And on top of that, we call it profit. So just remember this formula, V equivalent to C plus P. We are going to use this formula again in the cash flow calculation. Okay, and a lot of people will get confused with these things due to the fact that the issue of the data that we are going to give, whether we are going to give based on the value of the works or cost of the work. Okay, value and cost basically will refer to this formula. Okay, what is the direct cost? Direct cost is very simple. The cost that used to pay for what? Material, M. Machine, another M. And another M is basically labor. We call it manpower. Manpower that we refer to are the workers, the labor, not the professional people. The professional people's salary will go under the indirect costs. Indirect costs, better known as the overhead costs. The cost we need to basically manage the project. And of course, we need to pay what? We need to pay the utility bill, we need to pay the office, we need to construct the office or even rent the cabin, for instance, the cost of safety and health, welfare, the salary of the personnel, including the project managers and engineers, etc., etc. Everybody that normally sit in the site office, that's what we call management team. And some portion of the headquarters, what we call bill, also being sponsored by the project. So that's why it is very important for the contractor to have project. Otherwise, they cannot survive because the project is being used to finance the overall things, not only the construction side, but the headquarters. Some portion of the headquarters cost will basically taken from project. Okay. The relationship between time and cost. This is what we call cost, and this is time. If we plot 2 point meaning to say the in terms of the highest, the long period, the longest period, and the shortest period of the project. They could be possible, isn't it? We can construct something. Normally, it will take around 3 years, for instance. Let's say this is what we call normal. This is the shortest point. 2 point, okay? 2 point here and 1 point here. That is example. For the indirect cost, because the nature of indirect cost, it basically involves these kind of costs. It basically goes very well with the what we call the concept of the longer you stay in the office, for instance, site office, the more you are going to pay. You are going to pay more rent, you are going to pay more utility bill, and etc., etc. But of course, if you shorten the project, and the bill will be reduced. As simple as that. So indirect cost relationship, cost versus time relationship is linear. Very straightforward. But when we talk about the direct cost, since direct cost is related to 3M, man, machine, and material, you can relate to the real practice. Sometimes when you extend the project to a very long period of time, the longer you stay at the construction site, the more cost will incur in terms of what? Let's say material. material price could increase suddenly out of what we call nothing. For instance, the war broke out. Now we have seen sudden changes in the next month. For instance, I don't know, we are going to run short of material supply, and at the end of the day, the price would increase. Similarly, how about the machine? When you do not complete the project yet, of course, the machine cannot be released. You need to hire the machine on and on again, and you need to pay for the machineries. Similarly, manpower. The more time that you have, for instance, you need to basically pay the salary of the workers. That is the issue. Okay. So that is the kind of relationship, curve in nature. But if we are talking about 2 point, this is what we call the longest point, the longest period and the shortest period. If, for instance, we reduce the construction period, like what we have seen in the videos, the China construction videos, we could possibly reduce the direct costs. If, for instance, we have done with the machineries, then we no longer pay the rent, isn't it? That is the concept. If we can shorten the project period, we basically avoid the price escalation, for instance, due to whatever reason, that could be possible. And we can reduce and reduce and reduce until 1 point. This line reflect whatever thing that happened. There is always what we call optimum line. Optimum line whereby that is the best, okay, the best possible cost utilization, for instance. Either could be direct cost or indirect cost. But then, if, for instance, you want to further reduce the time, you notice that the cost, especially the direct cost, will start to increase. Very similar to the one that I mentioned to you, the food delivery or e-hailing. If, for instance, you want it much faster, normally you need to pay extra, for instance, but there is only a certain extent that it can be faster anyway. That is the thing. And whereas this line, total cost, when we add the direct cost and indirect cost point, it will basically account for the graph that looks like more direct cost, since 90% of the cost will be coming from direct cost and only 10% will be coming from linear, will be coming from indirect costs. So that is the general view in terms of cost relationship. If, for instance, we make comparison between 2 points, what is the point? The normal point means to say normally we can construct something according to whatever time that we plan initially, and then this point is basically the shortest possible time. Okay. Then another issue, this line in the middle of the line. In the middle of the line is the optimum cost. By right, if the project is being well designed by project manager, planner, and scheduler, by right, they should be very creative in order to come up with the best possible cost saving because of this issue. V equivalent to C plus P. If, for instance, they want to maximize the profit, they need to basically reduce the cost. So perhaps this line, okay, this line, if project manager, scheduler, and planner are creative enough, they basically would design the project initially in terms of scheduling, for instance, at this particular point. okay, at this particular point. So this is the issue. What if this, the original graph, we delete the right-hand side of the graph. So we delete, so it looks like this. So meaning to say, if project manager, scheduler, and planner are creative enough, they would have basically designed, okay, the project so that the project basically start basically at the minimum cost. This is what we could, this line indicate the normal duration. And this point indicate crash duration. Crash duration meaning to say the shortest possible. This is the normal. Instead of like this, the normal one is here. But there is a possibility when, for instance, the management wanted to reduce the project duration, well, they could basically reduce it further. But then there is a possibility that if they do not know this line, for instance, then they are going to start to see the cost is going up again. That is the things, the issue. Okay. But if, for instance, we already started at the minimum cost, okay, then what happens if we want to reduce the period? Okay, if we want to reduce, for instance, the indirect cost, reduce, it looks like the indirect cost will follow suit, will follow our reduction in time because it is linear relationship. Okay, for indirect cost, it's easy. But for the direct cost, what happens is that when we start reducing the period, we are going to start, there is an increase in the cost. So this is the assumption that we are going to use in the subsequent example. Okay, meaning to say, we assume that the scheduler, project manager already come up with the best possible cost for the project. They managed to find the point, okay, but then when they start to reduce the project duration, they are going to see some escalation of the direct cost for sure, whereas there could be cost saving with regard to indirect. But indirect cost, it is not that much. It is only 10%. The majority of the cost will be coming from the indirect cost. So whatever it is that you do, if you look at the total cost, of course, it is going to be increased as well. The issue is that why basically you want to shorten the project time out of sudden. Normally, we do not do that because we already designed everything perfectly according to whatever time that could be considered as reasonable. There could be reason. First thing first, it is the client that requested the things to be shortened, to expedite. Let's say we get a project originally given by a client 2 years. We already started for a few months, and then the client come to us and ask us, hey, can you speed up the project so that instead of 2 years, it basically become only 1 year. Okay, that is the things. Why? There could be many reasons. The client is target for grand opening of the building, so that when they open the building, they can get more profit. For instance, they are operating hotel, etc., etc. And the faster they get the profit, for instance, the faster they are getting rate of return. And on top of that, because they are making money, why don't they share the estimated anticipated profit with the contractors? And as a contractor, what would be your response if the client call you one day and asking you to do so? first thing first, as a contractor, normal contractor would say, yes, yes. The first thing that you must say as a contractor to look and sound confident is yes. But there is a differences between smart contractor and dumb contractor. Okay, smart contractor would say, yes, we can do that, but give us some time, like a few days, so that we can go back and look into the numbers, and then basically bring those methods to discussion. That is what smart contractors shall respond, because you do not want to say something at the end of the day, you are going to end up losing. Because remember, you already calculated all the things at the beginning of the project. Now, it seems that your plan basically has been spoiled. Okay, you do not want to do that. Number two, delay incurred. Let's say your project is 2 years. Okay, the normal duration is 2 years. You already started like half a year. Then suddenly something happened. Maybe it is raining every day. Maybe due to you cannot get the material due to the war going on, etc., etc. So instead of finishing the first 6 months, so meaning to say remaining is 3/4, 75%, but you only manage to progress like you are supposed to progress like 25%. You only manage to progress like 10%. So meaning to say, 3/4 of the coming period, you must really speed up. Okay, not 75%. You must, because you know that the remaining period, the remaining activities like 75% plus 15%. Wow, 90% more. But the time remaining is only 75%. So meaning to say you need to speed up in order to avoid what? Penalties. Okay. So you cannot basically progress work as usual because you know you are running late. Okay. You speed up. Number three, contractor getting a new project. Let's say you are working on the current project, very good, but then suddenly you are getting a new project. Maybe the project is nearby, whatever, okay, a new block, a new phase, whatever, in a big piece of land. So you already have machineries. Example, you already have machinery that you own, you do not rent. If, for instance, you can speed up your activity or task in this particular current project, those machinery can be released. Those machinery are no longer needed, and then can be released to your new project. And now you can have a cost saving. You don't have to search for machinery to rent. You can still use your own machineries. And that is example. Another, number four, anticipation of adverse weather. In Malaysia, for instance, we do not have a four-season weather anyway, but we do have rain that happen. I don't know. Nowadays is rain could be coming out of season. A long time ago, the monsoon season or the rainy season would basically goes in the November and December. That's why we have a long school holiday during that time. But now it seems to change anyway. But let's assume that is the situation. So you are getting a project from 1st January until 31st December. Okay, 1 year, 1 year. But you know that in reality, you do not have a full 1 year to work with. Okay, so you need to speed up certain activities so that you can construct or finish the roof, for instance, of a building, the roof earlier than the original plan, for instance, in order to avoid the issue of the rain every day, so that you can still work internally. That is the example. Number 5, error in purchasing. Another issue. Let's say a contractor might buy things in bulk in anticipation of the rising price of material, etc., etc. But then there will be issue where to put the material. The material could be brought to the construction site. Now you are dealing with many other issues: space issue, stolen issue, and then weather issue. So you want to use the material as soon as possible. This is when you expedite some of the tasks that you already planned maybe later on. You expedite so that you can use the material right away. And the good thing is that once you start using the material, you utilize the material, place the material, then you can start to get payment. So you avoid the issue of cash flow issue. Okay, because you already purchased those things, you need to pay cash with the manufacturer, whatever thing. But then you have to wait for the installation, then only you are being paid. That is the normal practice. Why don't you expedite? Those are some of the examples. And how basically you shorten the project time. There are two ways. One is basically resequence the activities. Resequence the activities, this is just example. Okay, let's say you plan for finish to start certain activities or tasks. And if you do that, you notice the overall completion of certain activities could take long period of time because every activity finish to start. Why don't you utilize what we call lead, for instance, or you can even overlap, synchronize some of the activities. Okay, but if you want to do that, certain activities start at the same time. The only way you can do that is basically you need to use different team. You cannot basically use the same team again and again, because one team have to work on certain area, another team have to work on the other tasks. They cannot basically do the work both at the same time anyway. That is the logic. And because of that, you can see the cost will increase. Okay, because of you need to have two teams instead of one team. So that is what we call trade-off. You want to shorten the time because time could be very essential, but then you need to sacrifice on the cost. But there is a limit. There is a limit to what extent. This is what this slide is all about. We are going to calculate how much is the cost increase so that we can play around. If you want to reduce the time, to what extent we can reduce, because whatever it is, the cost will increase. The limit to how much the cost increase, because everything in terms of resources are limited. All right, number 2, accelerate, crash, some or all activities. What does that thing mean? Okay, let's see. Originally, I planned the activity to be that long, maybe like 10 days. Okay, 10 days. If, for instance, I want to cut the activity instead of 10 days into 5 days only, what does this thing tell us? Remember, how do we get 10 days initially? From the concept of what? P equivalent to Q divided by T. Q is the quantity of works, and the quantity of work remain the same regardless whether you want to shorten it or not. It is the same. The only differences is this equation, this and this one. So meaning to say, if you want to reduce the time, you need to increase the productivity, as simple as that. Productivity basically related to what? How much quantity that group of people or one person do in terms of a certain period of time. If, for instance, one person can only do that much, if we want to reduce the period, of course, you need to add another individual, okay? And if, for instance, you use one individual manually, you need to give that guy some kind of tools so that productivity can be increased. That is the relationship. So whatever it is, if you want to reduce the activity period or task period, it basically has to be linked with the resources that you use. What kind of resources? It could be manpower, or it could be machinery, or it could be a material that advanced type of material that can be installed quickly. Okay. Usually a project was prepared to complete at minimum cost. This is what this graph is all about. Okay, at minimum cost. That is our assumption. From now on, our assumption is that the project has been designed that way. Those shorten it would increase the cost. This is our assumption. Even though we know that if we take to the certain extreme, there could be possibly that we can reduce the cost further, but then there is a certain point. Okay, we are going to see those examples. Number two, it is really feasible to completely crash either an activity or a project. This is a very important point. Once we go through the example, then you are going to see in a project, there are many activities or tasks. We do not simply just crash one activity for the sake of compress the overall project. Sometimes it doesn't work that way. Sometimes it is very insignificant, very minimum. And why basically you want to do that? You are going to crack your head, but then you are going to get a minimum outcome. We normally do not do that. Or we compress all the activities, the whole project. That is another issue. Later on, when we go into the example, perhaps you can see not all activity can be compressed, or basically, even though all activity can be compressed, but then the cost could be very much, to the extent that you might not be it might not be affordable. That basically go against the concept of the project anyway. Okay, in a project, for instance, you want to complete the project within time. Cost is always an issue. And lastly, shorten the project to some desired duration at the least cost. This is another two important thing. Some desired duration, meaning to say, normally, once we do the simulation in terms of what the time that we can, how much of the time that we can reduce, and how much the cost increase, and then we are going to decide. We are going to shorten only few days, for instance, because that basically will tie up with the cost, the budget that we can afford. Whatever it is, from our assumption, when we basically reduce the project period, the cost will increase. But we try to control so that the cost increase is at minimum. So in order to do that, we need a creativity. Creativity in terms of what? In terms of when you want to reduce the overall project duration, you must take a look at what are the activity that best, okay, that best compared to others, in order to basically further reduce the project, while the cost increase is kept at minimum. This is what this point is all about. Okay, later on we are going to translate this point into a proper example. Perhaps you can see how to crash activities. Item number 2, is the issue of crashing activities. How to crash? Working activity on multiple shifts. In normal construction, the best practice is basically to work a normal shift from maybe 7 o'clock until 5 or 6, whatever. That is the best. If, for instance, you can go for 2 shifts or triple shift like manufacturing, that would be fantastic. Of course, you can shorten the period at maximum, but the issue is that possible? Okay, because construction, you need lighting a lot. Okay, but certain area in urban area like Kuala Lumpur, for instance, if you go to KLCC area, you can see the construction site, non-stop construction, new construction site coming up, and they need work at night because of certain heavy machinery or truck, for instance, cannot enter city during certain time. That is the issue. Number two, working extended hours. Instead of working on multiple shifts, why not extend the hours? Instead of going back at 5 or 6, extend a little bit until 7 or 8, for instance. If, for instance, you can cover or finish certain works every day, bit by bit, that would be better. Number three, bringing larger equipment. Normally, we already calculated what output of machinery that we are going to bring in, okay? And the output of machinery normally are being tied up with the carrying capacity of the machine. If, for instance, we just bring in a small crane that can carry up to certain load, why do now we bring a bigger crane so that at one go, for instance, that crane can carry much more, so it can do the work faster. But again, bigger machinery mean more costs, as simple as that. Additional equipment, of course, instead of one excavator, one crane at all time, now you increase into 2, 3, 4. But again, bring more machinery, mean to say more money has to be paid. Putting more men on job instead of just a few people working on the same trade, for instance, now bring more. And of course, you can get more productivity. But again, bringing more people, more machine, etc., if you do not plan properly, it will turn into waste as well. Have you heard about machinery idling? Men idling, doing nothing. They're just looking around. You cannot blame them because you are the one that planned the work for them. If you fail to plan, that is what happened. Still, you have to pay them money anyway. Once they come to the work, regardless of whether there is a work or not, then you have to pay them. So that's why planning play very important things. And lastly, by putting, using more costly, this is what IBS is all about. For precast concrete, as you have seen in the video that I shared you earlier, the only way to go about reducing the project, for instance, using precast panel, precast concrete, even some of the building in Hong Kong, in Singapore, I have heard, Hong Kong especially, you can search the YouTube, high-rise building, they basically, they fabricate the whole unit, floor unit, in one piece. What they simply do is basically lift one piece at a time, put it together. You see, the whole building now can be complete much faster because you don't need to install bit by bit certain panel. Now the whole piece of the whole unit, including the bathroom, kitchen, living room, everything. Once you put them into a unit, the only thing that you need to do is basically to patch here and there so that it basically looks more consolidated anyway. Okay, so that is the reason. Okay, now let's go back to the concept of P equivalent to Q over T so that you understand. In order to reduce the number of period, duration for certain activities, you basically need to increase the productivity, but at the same time, the cost might increase. Okay, let's take a look at this example. This example basically use the concept of scaffolding installation, tubular scaffolding, the normal scaffolding. Let's say, if for instance, we use four crew that consists of what? One scaffolding set, two laborer, one carpenter, and one carpenter foreman. This is what we call the productivity rate, P, productivity rate. So four crew can install 1,300 square feet of the area, scaffolding area. Okay, we measure by area. Okay, construct the area, and then if, for instance, we increase the crew into 5, what is the difference between 4 and 5? We increase one carpenter. And when we increase 5, you notice that the productivity is much more. The output capacity much more. And then we increase 6. And when we go into 6, we maintain everything still the same, except that scaffolding now have 2 sets. Laborer now have another extra. That is a big jump from set 4 and 5. And then we go into 7. And you notice that the productivity is much more. And we add one more carpenter. And each of the item here basically can be calculated in terms of the cost, because we know how much the scaffolding set costs, how much is the laborer, wage, carpenter foreman, etc., etc. This is just an example based on whatever current cost anyway. Okay, this one. What is this thing? This is basically using the concept of P equivalent to Q over T. Now we are going to calculate the T. So if you want to calculate the T, you just simply reverse this equation. T equivalent to Q divided by P. Okay, so Q, this is the Q, the quantity. Let's say we need to basically install this much area, 84,000 square foot, divided by the first one, 1,300. So this is just example. And we are going to get this duration. Remember, how do we calculate the duration? Using this concept. This is what we call productivity rate. Okay, productivity rate. Okay, if we can calculate like this, then we can calculate for every of the situation using different crew, because different crew will have different productivity, in order to see which one costs how much. This is what we get. Okay, for instance, using 4-number crew, this is what we already calculated in the previous slide, and we can round off like this, and we can calculate the cost using round off or basically certain decimal point. Okay, let's focus on the round off. It is easier. Meaning to say, we use 4 crew and then 65, right? We run off into 65, and this is the cost that we calculate using 4 crew members. Crew meaning to say, this scaffolding, 2 laborer, 1 carpenter, and 1 carpenter foreman. Okay, now let's go into 5. Let's say we increase the size crew into 5. We can reduce further, and how much is the cost? You notice that the cost, instead of 34, now become 33. It looks like the cost basically decreased. This is what this graph is all about. Remember, I told you at the beginning here, there is a possibility of the cost basically decrease like this. You see? Let's say we start at certain point. When we try to reduce the task duration, they could be decreased in terms of the cost. This is what the graph is all about. And you notice that what happened if we go for the crew number 6, crew number 6, we can reduce further. We can speed up the project because it basically use 2 scaffolding, 1 extra carpenter, etc., etc. And you notice one thing. Now the cost start to increase again. And when we go into using 7 crew, and the cost basically start to increase. And that is consistent. When you use the concept of like this from the beginning, we say, we can reduce, but then when you reach certain point, if you want to reduce further, now you can see the cost basically start to increase again. So this is the whole scenario. But the issue is that the project manager, scheduler, and planner at the beginning, they can play around. They can play around with the schedule and to basically arrange things in such a way in order to see how much is the cost with respect to different way of putting things together. If, for instance, after they already get those kind of things, at the end of the day, they need to decide. Okay, they need to decide. This is what the graph we are talking about. Okay, so from now on, we just basically use the concept that we do not want the other what we call values on the right hand side of the graph. We assume that the scheduler, planner, and project manager basically already plan something based on the minimum cost. Okay, so this is the thing. And if we already have this kind of data, we plot into the graph, then we can see some kind of relationship is developing. Okay, some kind of relationship is developing. It is like this line. Number 1, number 2, number 3, number 4 basically reflect the value that we mentioned before, like this, for instance. Then we can see that there's a line here that could connect between those kind of point. And this line is what we call cost slope. What is cost slope is all about? Cost slope basically indicate the constant, okay, constant, the constant value that we can relate to cost reduction for one activities, and subsequently for all the project that consists of that activity. At the end of the day, if, for instance, we want to reduce certain activities, then we know how much is the cost is going to increase with this constant value of the cost slope. Okay. The straight line here, the dotted line indicate the straight line. The straight line is what we assume based on some this data, for instance. We assume the cost slope to be straight line, but in reality, it is not the straight line. It is going to be curved like this. Curve like this. And if you see this curve, you might basically notice that we have shown you this curve before. Example, this is the curve that we refer to. We can basically, if we refer to the direct cost, this the same curve. If, for instance, we already take into account the indirect cost, but see the curve looks like this. This is the curve that reflect the relationship between possibility of such project to be completed at normal time, and then another possibility at the crash time, and we can see the relationship. Okay, because of the this relationship, for instance, in order to make it easier, we are going to use the concept of straight line. Okay, this straight line will tell us the cost slope. How do we get the cost slope? Okay, let's assume we have 2 points. This point, we have 2 points only. This point indicate normal duration. A normal duration of executing an activity or a task. we can do a task. Let's say we can concrete a slab. Okay, we can concrete a slab for a room, whatever, in 7 days. So that is what we call normal duration. Maybe to construct a slab, we normally need the formwork, we need the rebar, and we need the concrete. Okay, and of course, manpower, etc., material, etc. We count those costs. So this is what we call normal costs. So normal duration to construct a slab, 7 days. Let's say 7 days. And how much is the cost? Maybe like 1,000 ringgit. That is a normal cost. But then what happened if we want to crash the slab construction activities? What is the shortest period that we can? Can we construct in 1 day? I don't think it is possible. 2 days. 2 days is very difficult. How about 3 days? 3 days maybe sound logic. Okay, let's say 3 days. So that 3 days, we call it crash duration, 3 days. Based on normal practice, based on normal practice. And how do we get 3 days? If we want to speed up, for sure, we need to add more manpower. We need to add more, what we call, more period of time. Instead of working until 5 or 6, we need to extend a little bit so that we can complete the activity much faster. And when we do that, we notice that the cost is going to increase because we need to pay more people. We need to basically pay extra time, perhaps even holidays, etc., etc. And how much is the cost increase? Maybe the cost increase like 1,500. So this is what the graph is all about. There is 2 points, okay? 2 points. One is what we call normal duration, and one is the crash duration. And because of that, we can see there is a normal cost and then increase into become crash costs. So once we have this kind of relationship, then we can calculate the cost slope using this formula. Using this formula. And how do we calculate the cost slope using this formula? It is given by using the cost slope is basically you take the differences between the highest cost minus the normal cost. So we need to say 1,500 and then 7 minus 3. 500 divided by 4. So this is what we call cost slope. Cost slope is the constant, okay? It is the constant. So how much is 500 divided by 4? Okay, let's say 500 divided by 4. You get 125. What does this 125 mean? 125 mean the additional costs. If, for instance, you want to shorten the project by 1 day, that is the additional cost. So we need to establish one thing. The normal duration, the normal duration is 7. If you want to complete the project 7 days, the cost is 1,000. But what if you want to shorten the project, instead of 7, you reduce it to become 6, meaning to say you reduce 1 day, isn't it? 1 day. So the cost now become 1,000 plus 125. You see, this 125 is the constant that we calculate before. That is what the cost slope is all about. Okay, the cost slope is all about. Similarly, you can take a look at this example. It's the same example anyway. Let's say we do have 2 points. One is the normal duration, 10 days. and the normal cost is 6,000. But then if we crash the project to the maximum which is allowed, let's say here, 4 days, but then what happened to the cost of the project? 10Ks increase. And how do we calculate the cost slope? Again, the cost slope using this formula, you take the higher cost, 10,000, minus with the lower cost, divided with the higher duration in the graph there, minus with the lower duration, which is crash duration, you get 667. So 667 is the constant for that activity. If you want to reduce 1 day, you need to add up 667 with the normal cost. So this is the normal duration. 6,000 for 10 days. But if, for instance, you want to reduce the project like 1 day only, so 1 day basically require extra 667. So what you need to do is basically add up 6,000 with a 667. At the end of the day, you are going to get the project need to be paid 667. And then, of course, you can complete the project by reducing 1 day. Okay, now the project becomes 9 days. So now you already know the relationship. If, for instance, each of the activity you know that kind of relationship, then it is much easier. You put it into the whole network, because remember the whole network diagram. The each of the activity do not run one by one in one go. Basically, sometimes they can run parallel, synchronized, overlap here and there. So that's why you need to look at into the whole network diagram. Then only you can see how much the cost increase or decrease, etc., etc. The cost will increase, but the time will be reduced by how much. Okay, you need to put this concept into the network diagram. But this is just the beginning. Whatever thing that we do, there is some kind of constant relationship that tell us relationship in term of what? In term of cost increase and then time reduction by using the concept of the cost slope. Okay, now step in crashing the project time. How do we crash a project time? Okay, how do we crash a project time? We can basically do this. First thing first, solve the network to determine the normal duration. Okay, solve the network to determine the normal duration and critical path. Normal duration, meaning to say the overall project completion. This is the overall project completion first. And then the critical path. Network diagram. Okay, network diagram can be anything. AOA, AON, or PDM. So that's why I mentioned to you, whatever thing that we learn the second half of the semester basically involve the application of planning and scheduling. We expect you by now are able to basically construct the network diagram based on whatever information given. Because from now on, we are going to apply those things. So you need to basically able to construct in order to get the normal duration and the critical path. In order to get the critical path, you need to basically to calculate, be able to calculate the total float, so that whatever total float equal to 0, those activities are being considered as critical activities. And then number 2, calculate the cost slope using this concept. Okay, using this concept. But of course, in order to calculate, we need data. But if, for instance, in real situation, in real life, the data are not there, and then where do you get the data? The data is the one that you basically need to basically construct. Okay, the data, you need to come up with the data first based on what is the normal practice. I have given you, for instance, let's say we want to construct a slab for whatever size of the floor. So the normal practice would be, like say, 1 week. And then how much that we can crash the project until we cannot crash anymore. Let's say 3 days. If we go for 2 days, 1 day, it is not possible. Okay, and then how much if we need to reduce and how much the cost increase. And that is the data that we need. But in our class, we are going to give you data. And then number 3, you see, start shortening by selecting the critical activity with the least cost slope. Least cost slope means to say the cost slope which basically have a lower value compared to others. When we do have, like, say, 10 tasks, we are given 10 tasks, A, B, C, D until whatever. Each of the cost slope might not be the same. There are cost slope which basically cost more. There are cost slope which is basically cost less. So the one basically that costs less is much more preferred. But again, the one which the critical activities are the main criteria, but then you need to take a look at which one is much cheaper. Number 4, shortening process must be done in step. I sometimes call it step. I sometimes call it cycle. Cycle number 1, cycle number 2, 3, and 4, whatever. Okay. In some books, they call it step. Step 1, step 2. So meaning to say, in order to do this exercise, we need to duplicate the diagram. Let's say you already have AOA diagram or PDM diagram for the original network, and then you need to duplicate maybe a few duplication. Why? Because you are going to jot down your rough calculation using in the cycle number 1, cycle number 2, cycle number 3, 4, and 5, and only perhaps at certain cycle you are going to get whatever the answer. Like, for instance, in assignment number 2, there is a question with regard to project time cost trade-off. Maybe question number 2 or something. Okay. So you need to do until cycle number 5. Then only you are going to get the answer. It is not just simply do shortening, just one cycle, there you go, you get the answer. No, that is not the way. Okay, we need to do one cycle number 1, cycle number 2, cycle number 3, cycle number 4. Why we need to do that? Because whenever you do changes, you crash certain activities, and you need to do the calculation again because network are interrelated. That is the issue. And number 5, look for the formation of second, third, and so forth critical path. Okay, critical path normally in our class, because we only give you tasks that are not many, maybe 10 tasks. The most would be less than 20 anyway. And it looks like the critical task normally only one path. But if you remember in your assignment number 1, I think AOA diagram question 1, the critical task is not only one path. It basically goes into 2 paths, starting from one point, and then it branches out. One goes on the top, one is at the bottom, and then merge at a certain point. So there are basically 2 critical paths in question number 1 answer. You see? So critical path can be multiple, but normally we are going to start with one anyway, in a small project or small activities. But then when you start doing the project crashing, cycle number 1, after you finish cycle number 1, for instance, then you are going to see the another critical path could emerge. What does that thing mean? So when there are many more critical paths emerge in that diagram, so meaning to say there are more difficulties you are going to encounter when you want to start to crash another activities. Because remember, crashing activities must basically based on the critical activities, on the critical path. Otherwise, it is not going to work. So you need to start looking at many different paths at the same time, not only one activities. This is the challenges. Number 6, after shortening process, and then, so ultimately, we are going to know the cost of the project. We call it new total cost of the project. Consists of, it could be indirect cost plus direct cost. All this one is new indirect cost, new direct cost. And eventually, this is what we want to figure out. And at the end of the day, we want to know what is the new duration of the project. This is what our intention is all about. Okay. All right. So how do we do that? Let's say we do have one small project first. Okay. Before we go into a big one, one small project. This is what we call AOA diagram. AOA diagram. Let's say you already constructed this AOA diagram. This diagram consists of 3 activities, A, B, and C. Okay, there are 3 activities only, and whereas this is just the dummy activity, dummy D1 and D2. And first thing that we need to do is to construct the network diagram. Okay, we already constructed network diagram. Why we construct network diagram? So that we can do the calculation in order to get this value. This is what we call normal duration. Normal duration of the project. Normal duration. Normal duration means to say the overall project duration, this is normal period that we can complete the project in 10 days. What is the normal cost? The normal cost for this project is given. Normal cost. Normal cost is given 5,000 ringgit. So the project will start with 5,000 ringgit, and 10 days is the one that we already calculated based on our AOA diagram. And another thing is that we know that this is the critical path, task A only. Okay, so first thing first, we need to establish this diagram. This is what we call original. Original. Okay, original diagram. Original. Okay. All right. So let's say we want to compress step by step. Let's say I want to compress the project by 1 day only, from 10 days into 9 days. Meaning to say I will crash the project by 1 day. So what shall I do? Okay, I need to go back to this step. I need to go back to this step. But before we go into next slide, you notice that I write down here, I note down this information. What does this information mean? This information consists of 3. 3 meaning to say activity A can be crashed by 3 days only. Allowable limit. And each day, the cost is 100 ringgit. That is what we call the cost slope. And then activity B can be crashed 3 days only also, but each basically require a little bit less, 75 ringgit per day. And the cheaper one is basically C, 50 days. And if, for instance, we want to start crashing, we can refer to activity for item number 3. Item number 3 is telling us start crashing or shortening by selecting critical activity, activity A. Okay, activity A, activity A. All right. So activity A, and then is the critical. We do not go for the cheaper one because the cheaper one is not in the critical. Okay, let's assume. Let's assume you want to go for a cheaper one. Okay, you focus on activity C. Activity C, instead of 8, I slash 1 day. Now it becomes 7 days. And this activity remaining is 2. Okay, I do the whole calculation again. Even though I slash activity C can be completed in 7 days, but the whole project still remain 10 days. What is the purpose? It basically defeats the purpose, isn't it? But now you already have extra 50 ringgit that you need to bear. Where does the 50 ringgit come from? From here. So you see, this is the point. You simply do not crash activity for no reason. Even though you can crash activity C, but why? Because you crash activity C, yes, activity C can be reduced, but then the overall project still remain the same. So it basically defeats the purpose. So this is what the previous point that I already mentioned before. Here, this is the point that I already mentioned here. This is the things. Okay, you simply do not you compress thing which basically have no purpose. Okay, now we are going to compress the project. Okay, let's take a look at example. Let's say I say this is a cycle number 1. Cycle number 1. Okay, cycle number 1, you see, you notice that I jot down here. That's why I need to copy paste this figure again and again, because I need to basically jot down many things, and then I slash here. So meaning to say now activity number A, activity A is going to be done in 9 days. I slash 1 day, I crash 1 day. And activity number 2, the remaining 2 days more can be crashed. And you notice that when I redo the calculation, okay, I managed to slash the activity by 1 day. This is, you see, I reduced by 1 day. But how much is the additional cost? Because each activity A, the cost slope is 100 ringgit. If I want to slash by 1 day for activity A, I will have to pay additional extra 100 ringgit. So in cycle number 1, you notice that I can reduce the project by 1 day, but then the cost will increase by 100 ringgit. From where? From the original. Remember, the original is 5,000. But we do not add this thing yet. Okay, we can add those things at the end of the example anyway. But this is just to give you the whole idea. How basically we can reduce the project once we know how much is the cost load, etc., by doing this kind of exercise. And after cycle number 1, you notice there is a significant differences between the original diagram and the cycle number 1 diagram. You notice the critical path now become 2 instead of just 1. This is what step number 5 is all about. Look for the formation of second, third, etc., critical path. Now you see the critical path, the extra critical path emerge. Let's say cycle number 2. Cycle number 2, you want to reduce by another 1 more day. Okay, this is, I call it cycle number 2. Cycle number 2. Okay, you notice that the critical path based on cycle number 1 is only 2 here. And what I did is that I just slash and become 8 here, and activity A basically there is another 1 more day, and B now have to be slashed as well because they are both critical. And when I get 8 here, when I redo the calculation and I manage to get the project to be reduced by another 1 more day in cycle number 2, okay, by reducing both activity A and B at the same time. Why should I do that? Because if I reduce only A, it is not going to work. It's not going to work because A and B are having the same critical path. So I need to basically focus on those two. When I focus on those two, meaning to say the cost increase now become more. 100 ringgit for A plus 75 ringgit for B. See? An increase of 175. 175. This 175, if I add with the previous one, was 100. Now the cumulative become 275 in the cycle number 2. You see, that is the increase in cost. Cumulatively, okay, cumulatively is 275. Okay, now, cycle number 3. Let's say I want to further reduce by additional 1 more day. And you notice in cycle number 2, even C now become the critical. Now all the line become critical. If I want to go for cycle number, sorry, cannot write anymore. Cycle number 3 here. Cycle number 3, you notice that the critical paths are A, B, and then even C. So meaning to say, I need to crash A, B, and C simultaneously. When I crash 1 day each for A, B, and C, and of course, you notice the additional cost would be 100 plus 75 plus 50. Okay, plus 50. So this is 225. 225 you plus with the previous one, and then this is the cumulative 500 ringgit extra cost. And you manage to get a project reduced by 1 more days, or in total will be 3 days from the original. Okay, what do we get from this exercise? Now we go into the last slide. Okay, you notice that we can plot the whole relationship here. We can plot the whole relationship here in order to show you the issues. Okay, remember we start with 10, isn't it? We start with 10, and this is the normal cost given to us, 5,000. Then we did the cost, the time reduction. We goes into 9, and we goes into 8, and we goes into 7 only. But there are a few more data from the given answer. Let's assume you as a contractor, you are getting a project to construct a toilet or renovate a toilet from your client. Okay, so you give the client some kind of ideas or schedule. 10 days, you need time to construct a toilet, new toilet, or renovate whatever toilet. And the cost that you give to the client is 5,000. Okay, so your client basically initially agree with that. But then suddenly, I don't know, maybe prior to the project basically starting, the client basically asks you, hey, can you further reduce the time because I need the toilet very badly? Well, now you are bargaining with the client. Once you have the data, you can bargain. Okay, let's say you mentioned to the client that 5,000, 10 days, all right? But I can do a little bit faster The shortest that I can do is 5 days. So half of the time. But then the cost would be skyrocketed. It is like double, 10,000. You see, that is the extreme data that you give. One is the original and one is the crash duration and the crash cost. Oh, okay. The client basically, 10,000, double the amount, I cannot afford to. Okay. But then you can still give suggestion to the client. I can basically reduce if by 1 day, instead of 10, 9 days, but then this is the cost, my cost. If you want 7, for instance, I can give you this amount. Where do you get this data from? From this exercise. This is what we are telling you. So that you have some kind of information. You do not want to run the project or the activity at a loss anyway. You have all the data that you already calculated. Okay, so that it can be a bargaining tool to give a suggestion to your client. All right, so this is what project time cost trade-off is all about from the concept. But if, for instance, this is just 3 activities, simple activity, what if you have more data, more activities, like 1, 2, 3, 4, 5, 6, 7, 8, and 9 activities. We do not want to go through this exercise anyway. I just want you to look at the final outcome. Okay, if we have done the same exercise, okay, going through step by step, this is what we are going to get. For instance, we are going to establish the normal project will be running for 55 days, and the normal cost will be 38,800 based on whatever given data. If we have done cycle by cycle by cycle and by cycle, we get the data, and then we can plot the graph. And you notice that the graph that we plot, it is not a straight line. It is not the straight line. It is going to be curved like this. Instead of straight line, like this is if we have a few data only. But if you get a bigger data, we are not going to get a straight line. We are going to get a curved data. And this curve is exactly the one that we have been telling you for the past 1 hour. This line, you see? This line and this line. See, this line or this line is the same. This is the thing that I'm telling you. Once we have a lot of data and we do the exercise, at the end of the day, we are going to get that kind of relationship. Okay, so that we can play around, or you can discuss with your client. For instance, instead of 55 and the cost is 38,800, now you can basically want to reduce to how many days, and that is the cost that you give to the client. This is like a bargaining kind of thing, but based on the calculated data, of course, you are not going to run the project at a loss because you already calculated all the things. Okay, now we go into another example. Okay, another example. This is the data that we need. In our case, well, we are teaching you about the concept. So we need to say we are giving you the data. What are the data? First thing first, we need to give you the data about the task or activity in terms of the predecessor, in terms of the predecessor is the relationship, and then we are going to give you the normal time. The normal time is this is what we call normal duration. In our term that we use, this is normal cost. This is crash duration. This is the crash cost. Okay, remember, we need this information in order to calculate the cost slope. Okay, let's say item 01. How do we calculate the cost slope, sorry. Cost slope. So the cost slope for item number 01 is basically, you take the higher value of the cost minus with the lower value, 280 minus 210 divided by the highest value of the time minus the lowest value, 4 minus 3. So this is 70 over 1. So basically it is 70. 70. That is what the cost slope is all about. Okay, you can calculate the cost slope based on the given information. And one more thing, remember the word normal. So normally the project can be constructed based on this normal cost. You can add up this normal cost for each activity. At the end of the day, you know this normal cost, so that you can establish what is normal cost. Similar to this, you see the normal cost, so you can calculate the normal cost. This is what we call normal cost for the entire project. And in fact, this is the normal, the crash cost for the entire project to a certain extreme. You can calculate, you know already. But the issue is that, I tell you, the issue is that when we crash a project, we do not crash the project to the maximum. We only crash the project to the desired value. Remember the previous slide mentioning the desired duration and desired cost. So we want to know the simulation. Okay. Now, using this concept of step number 1 until 6, okay, based on the given data, how do we construct our example? Okay, first thing first, here, you need to construct the network diagram. Let's assume, based on whatever information, this is our network diagram. I use AOA diagram. AOA diagram. Okay. The AOA diagram is for us to construct the diagram so that we get the critical path here. The one shown in red. These are the critical activities. So now we know the critical path, and we also know the project completion duration. This is what we call normal duration. Normal duration is 22 days. How much is the normal cost? This is normal cost. So we already established the normal cost for the project is 3,050 ringgit. Normal duration is 22. And you notice that this is what we call the cost slope. From the given data, we put it there, and 70 for activity 01, 70 meaning to say the cost slope is 70, and 1 in the bracket meaning to say is the number of days that we can reduce for that activity, the limit. Okay, where do we get the limit from? From this data. You just take 4 minus 3, you know that it is 1. So 1 is the limit which is given in the data. Okay, so you put down the note onto your diagram so that the next step you are going to start what we call crashing. Okay, now let's say we want to start crashing on cycle number 1. Let's say cycle number 1. Okay, cycle number 1 here. Let's say I want to crash the activity by 2 days in cycle number 1. This is, I call it original diagram. Original diagram. Now I want to start cycle number 1. I want to crash the project by 2 days. Straight away 2 days. Okay? Straight away 2 days. So which activity should I crash. Okay, based on this step, based on this step, okay, let me erase here. Okay, based on this step, okay, based on this step, first thing first. First things first, item number 1 already completed. Cost loop, we already completed. Start shortening. See? Start shortening on the critical activity with the least cost loop. Okay, by looking at this diagram, the one that we focus is on the red colored line. Activity 01, 12, 24, and 45. Only. Don't bother about other things because the others are not critical. See, remember what the step number 3 mentioned on the critical activities. And the critical activity are the red in color. Okay, now, second criteria, look at the one which is cheaper in terms of the cost loop. And by looking at this thing, the only activity that I can think of is this activity. Activity 1, 2. It is on the critical path and it is cheaper. Another question is that, is it possible to crash that activity and see, because that activity is in the middle of network, we need to do the calculation so that at the end of the day, we want this value 22 to be reduced. So that's why we need to duplicate the diagram like this. Okay, this I call it cycle number 1. Cycle number 1, what I did was I just simply crash. I write down here, crash activity 1, 2. Crash activity 1, 2. This activity. I focus on this line, this activity only. Okay, and then I jot down, okay, I slash 6 here, and then 4 is the task duration that I want to stick onto this diagram. And 2 here is basically finish. Activity 1, 2 cannot be reduced anymore in the next cycle. And I do the calculation, okay. So remember, do the CPM calculation, 4 plus 4 equivalent to 8. So this is the value. But remember, 8, there is one activity coming from the bottom of the line. Activity 02. Activity 02 do have 8 days of duration, but you just simply add early start plus duration, 0 plus 8, also 8. Oh, now it is possible. Okay, possible to change the value here into 8 because both line from the middle and bottom there is possible. And then do the activity 24. 8 plus 5 equivalent to 13. On the top of the line, there is activity 14. Activity 14 basically do have 9 days. So you add with the 9 plus 4 equivalent to 13. So it is possible. 13 will stick into that box there. And the rest of the calculation, 13 plus 7 equivalent to 20. Let's take a look at the bottom of the line there. 8 plus 4 equivalent to 12. 12 plus 3 equivalent to 15. So 20 is the one that we get when we crash activity 1, 2. It is possible. Not only the project has been reduced, and the rest of the activity basically follow suit. See, now, after you do the crashing in cycle number 1, activity, you crash activity 1, 2. So the new project duration is basically 20, and how much money that you need to add up. Remember, activity 1 to cost 50 ringgit each. But since you basically reduce by 2 days, so 50 times 2 equivalent to 100 ringgit extra. So 100 ringgit extra, that is the extra. And how much is the original cost for this project? Is 3050. So the new project cost will be 3050 is the original. You plus with 100. So now 3150. So this is the new project cost, and the project can be reduced by 2 days, and the new project duration is 20. That is the data that you basically created after cycle number 1. But bear in mind, after cycle number 1, you notice that there is a formation of new critical path. Namely, this line, the top line, and even the bottom line here. And including the middle line here, of course. So if, for instance, you want to further reduce the project. Okay, let's go into cycle number 2. Cycle number 2, let's assume that I want to reduce the project by additional 1 more day. Why basically I go very slow? For instance, instead of go straight into how many days, I just go into by additional 1 days, because you need to look at the limit for a given for the cost load for each of the activities. So because of that limit, if you change anything, it might not basically change the whole project duration. So that's why you need to go by the limit, because the network diagram interact with one and another activity. So that's why you need to go very slow, one by one. Okay, let's go cycle number 2. Oh, for the cycle number 2, I have 2 scenarios. I have 2 scenarios here. Scenario number 1, I shorten one more day, but I crash this activity. Activity 1.4 and 2.4. Remember, this activity cannot be crashed anymore, but I focus on the activity 1.4 and 2.4 here. This activity and the top activity. Both. Why? If I just simply crash activity 2.4, it will not basically change anything since we get stuck here. This is the issue. So that's why I crash on the top of the line and the middle of the line. Okay, let's crash activity 1.4 on the top. So I jot down here 9, and then it become 8. So 8 plus 4 equivalent to 12. Okay, so that is the value. But how about the middle of the line, 2.4? 2.4, initially 8 plus 5 is 13. But if I change into 4, 8 plus 4 equivalent to 12. Now I manage to basically reduce by 1 day. And how about the rest? 4, 5. 12 plus 7 equivalent to 19. Okay, how about the bottom one? The bottom one is still 12 plus 3 is 15. So we managed to basically crash the project by 1 day by crashing activity 1.4 and then 2.4. Okay, each at the same time. But then the cost will be a little bit higher due to the fact that we need to crash 2 activities. How much the cost here? 30 ringgit for activity 1.4, 90 ringgit for activity 2.4. So the increase of 120. 120, if we add with the previous increase that we already slashed activity 1.2, now our extra total cost would be 3270 for scenario number 1. That is one possibility. Okay, now let's go into scenario number 2. Still trying to crash activity 1 by an additional 1 more day, but instead of focusing on activity 1.4 and 2.4, now I focus on activity 4.5, the easy one. The easy one because it is at the end of the line there. Of course, whatever changes, it will directly change the project duration anyway. But it basically more expensive. 150. If we add with the previous cycle 1, crashing, then we are going to get this amount. You see, you notice that in scenario number 1, I get 3270. Scenario number 2, I get 3300. Little bit more expensive, but I managed to fulfill the obligation of reducing by 1 day, both in both scenario, except that the cost differences. Okay, now let's take a look at the final solution for this diagram. How to read this diagram? Okay, this figure. This figure simply tell us the project normal completion is 22 days and the project normal cost is 3050. How do we get this? From the question given here, 3050. That is what we established. Okay, then what I did was I reduced the project in cycle number 1 by 2 days, and I managed to get extra. I basically increased the cost by 100, and the new total cost is 3150. Okay, but then this is the issue. Let's focus on the 19 days only. When I reduce the project by the additional 1 day, I use scenario 1 and scenario 2. Scenario 1 and scenario 2. Scenario 1, I get 3270. Scenario 2, I get 3300. But the answer given is 3260, which is less than what I can get. Why is it so? Okay, you notice in this example, they basically crash three activity instead of two, or instead of one. Okay, crash three different activities instead of two or one, which basically I did in scenario number 1 and scenario number 2. And this basically come into the conclusion. You notice that when we start, 223050 is the baseline. Then we go into 20, and this is what we get. But when I go into the 19, I didn't get this amount. Instead, I get 3270, and I get 3300. But what does this figure tell us? This figure simply tells us, if, for instance, in our class that we have how many people here, if one of you did this exercise using your creativity, whatever thing, you might basically, some of you might get this value, or some of you might get this value and this value, and whatever value, until somebody can get this value, maximum. And it is not to say it is wrong if the focus is on the project reduction. So everybody basically right, they managed to crash the project into 90 days, but the only differences is one can get the lowest value, whereas another one could get the highest value. Which basically which answer is the correct one? It depends on the question. And again, we go back to the fundamental of this subject based on this slide. This slide, where is it? Here. This, you notice, this is the things we mentioned here, this point. Okay. It is rarely feasible to completely crash either an activity or project. Shorten the project to some desired duration and the least cost. This is the thing. We must remember, whenever we crash a project, because the original project was being designed at the minimum cost already, when we try to crash a project, of course, the cost will be increased. But it is always our intention to minimize the increase of costs as much as possible. So if if the question basically is asking us not only to reduce the time of the project, but to keep the cost at minimum as possible, the only acceptable answer is this one, 3260. Because to fulfill the intention. But of course, if for instance, the question is just simply ask you to reduce the duration of the project activities, project duration, and the cost is not being mentioned to be kept at the lowest possible, then any cost that you mention along this line is acceptable. Okay, that is the thing. So meaning to say, actually, in order to do this exercise, this project scheduler, project manager, or planner, whatever, they have to be very creative. They have to be very creative to find ways. What is the best possible ways in combination so that the increase, of course, is being kept at minimum. And most of the people might not have the time to do so, especially when they think that why I have to crack the head to maximize the project the project profit, whereby the profit will go to the boss anyway. I'm not going to get anything. That is the thinking. Unless the project is yours, this is your company, and you are the one that do these kind of things. Maybe you can go all out to figure out ways to basically get the best. Okay, we go into the last example of the day. Okay, now let's say if you are given a, normally, even in your assignment number 2, you are given this kind of data. What kind of data? You are given an activity, and then the predecessor for sure, because you need to construct the diagram anyway. But inside here, we do not give you the predecessor, that's okay. So you are given normal duration, ND. You are given crash duration, CD. You are given normal cost. And then you are given crash cost. Okay, all the data is given. So immediately you know one information is not given, cost slope. So you can calculate the cost slope very quickly, cost slope, by using the formula of what? Okay, let's go into one example, activity A. Cost slope is given by, you just take 14,000, 14 minus 12, divided by 120 minus 100. Okay, so basically this is 20, you are going to get 100, 100, okay, 100 for activity A. That is the cost slope. You can calculate that, okay, one by one, quickly. And then, so you can establish cost slope. Then you can establish normal costs here. If you add all these costs, then you are going to get the normal cost. How much is the normal cost? Normal cost is 48,300. Okay, now we already know the normal cost. The cost slope for each we already have, but we need to construct the network diagram in order to know the normal duration for the project, the original duration. Okay, how do we do that? So we need to construct the network. This is what the network diagram is all about. Okay, using AOA diagram, PDM diagram, doesn't matter, because the only thing that we need to do is to get the critical path. The critical path is being shown on the yellow color there, B, C, D, E. And then each of these item is basically the what we call the cost slope is being shown here. Cost slope is being shown. for each activity so that we know when we want to start crashing, we must focus on critical activities plus the activity on the critical path, which is much cheaper. That would be the priority. Okay, but then this example have a plot twist. Plot twist in terms of what here? This is the data that we give you. Assuming the information given here is just the direct cost. Okay, the cost that we give you is basically referred to the direct cost. Meaning to say, we need to calculate also the indirect cost. And eventually, indirect cost plus the direct cost will be the total cost. And that is the normal situation. Let's assume the indirect cost given for this project is 50 ringgit per day. So now we need to establish how many days the project required to be completed. So that's why we need to construct the network diagram. At the end of the day, we get this value here. This is what we call normal duration, 140. Once we get the normal duration, then can we calculate the indirect cost? Indirect cost equivalent to 140 days, and each day costs us 50 ringgit. At the end of the day here, we get 7,000. This is what we call indirect cost, 7,000. What is the direct cost? The direct cost is given already. We get from here. This is the direct normal cost, because now it say that it is now the given one is the direct cost only. Okay, so once we get the direct cost equivalent to 48,300, what is the total cost? Total cost, indirect cost plus direct cost. You just simply add both of them and you are going to get 55,300. So this is the what we call the total cost, total normal cost for this project. Because the one given is just simply the normal direct cost. Okay, so this is the cost that we are going to establish. We call it original. This is normal or original. Original diagram. Original. Okay. Then what you need to do is basically copy and paste the same diagram again and again, because we are going to do a few cycles. I call it cycle. I call it cycle 1, 2, I think until cycle number 5. Okay, let's say now we already established we have 140 days. What if I want to crash the activity by how many days? I will start with 10 days. Why 10 days? Because it looks like many of the activity on B, C, D, and E, the allowable limit will be either 5 or 10. So perhaps I can start with the 10 days. And you notice that there is a cheaper activity among B, C, D, and E. Okay, on cycle number 1, here, cycle number 1, I will crash activity D. So focus on here, this activity, this D. Focus on here. It is where the calculation will take place. And what shall I do? I just slash here 30 to become 20. 20 is the one that I will put as the duration. I crash as if I crash 10 days. And then 10, the remaining balance is 0. So meaning to say the next cycle, I cannot crash activity D anymore. Okay, how the calculation will be affected? So I'll start with 60, 60 plus 20 equivalent to 80. Okay, how about the bottom one? The bottom one, F, 20 here plus 60 equivalent to 80. Okay, it is possible. And then 80 plus 50 for E become 130. And how about the top of the line there? A is 120. So now we have the 130 days, meaning to say we are able to crash by 10 days. Okay, it is fine. So now we are able to crash by 10 days. And how much cost increase? See, you notice here, activity D. Activity D, the cost increase, each day we require 60. So this is 60, I time with 10. 10 times 60 equivalent to 600. 600 meaning to say additional money that I need to spend. But the good thing is that once we do have direct cost and indirect cost kind of relationship, you notice the indirect cost from the graph here, from the graph that we already mentioned at the beginning, this one, this graph. You see, there is a direct or linear relationship for the indirect cost. So meaning to say, we can have a cost reduction for the indirect cost because now the project being decreased by 1 day. And I will put a negative sign. What does negative sign meaning to say? This is a cost saving. By how much? Each direct cost require 50 ringgit, and I can reduce the project by 10 days. So 50 times 10 equivalent to negative 500. For the D, there is an increase in cost, but then there is a reduction in terms of the indirect cost. And the net increase for cycle number 1 is only 100. Why? 600 for D increase, and then 500 for the indirect cost. The net increase is only 100. This 100, I add back to the previous cost here, 55,300. And I can conclude that this is the new cost, 55,400. And the project is going to be completed in 130 days, meaning to say I managed to crash activity D by 10 days. That would be the cycle number 1. And after I did cycle number 1, you notice the yellow colored line. Now, activity F appeared to be critical as well. Okay, now let's go into cycle number 2. Cycle number 2, I want to reduce another 10 more days. 10 more days. You notice that activity D cannot be crashed anymore because it is done. Okay, the remaining B, C, E, and F now can be reduced. So which one do you prefer? Of course, you need to take a look at the one which is cheaper. Well, looks like the cheaper one would be E. Okay, now cycle number 2, I crash activity E. Okay, let's take a look at the calculation. That's why you need to duplicate the network diagram, because every time you make changes to the activity duration, you need to recalculate and see whether it is possible or not. You do not want basically to reduce that activity, but then the whole network diagram is not being reduced at all due to the fact that it is interrelated with other tasks. Okay, now let's say I focus on this E. Okay, I focus on E. So the calculation from 80 plus the reduction by 10 days, I take only 40, the value. 80 plus 40 equivalent to 120. Okay, possible by 10 days. But how about the top of the line here? The top of the line is 120, so it is possible. We reduce by 10 days, activity E only, and how much is the cost increase? Remember, activity E require 120 ringgit for 1 day. If we reduce by 10 days, 120 times 10 equivalent to here. This is the amount for activity E. Increase 1,200. But we can have a discount on the indirect cost. How much? Again, indirect cost is 50 ringgit. And since we crashed 10 days, 50 times 10 equivalent to negative 500. That is the notation that I put here. In conclusion, the net increase is plus 700. Plus 700. What I did was I just add with this previous value. Now I get a new total cost 55,100, and the project duration is 120. Cycle number 2. After cycle number 2, you notice that all the line now become critical. Okay, become critical, and activity D and E cannot be crashed anymore in the subsequent cycle. Now we can focus on A, B, C, and F if we want to further reduce. Okay, cycle number 3. Cycle number 3, maybe I start with 5 days reduction only instead of 10. Why? Because B, it seems that the allowable limit is 5. So I want to start with only 5. Okay. So cycle number 3. Cycle number 3, I reduce activity B and A. B and A. B and A only. So B is here, and then A is here. On top of that, I cannot simply reduce B alone, because I reduce B alone, A is not going to reduce in terms of the timing, and at the end of the day, I cannot reduce the project duration from 120 into 115. But if I crash both A and B, it is possible. So I redo the calculation again, focus on A and B. So it looks like it is possible to reduce the project at by 5 more days. But then there is an increase. For A basically costs 200 times 5, which is 500. Sorry, B is 5 times 200, which is 1,000. A only require 100 times 5, which is 500. So the total increase is 100, 5,000, 1,500. But then the reduction in terms of indirect cost is here. 5 days only. 5 days basically we can reduce by minus 250. So net increase for cycle number 3 after I reduce 5 day each for A and B is 1,250. Okay, 1,250. You add back with this value, you are going to get this amount, 57,350. That would be the new project duration for 150 days. Okay. All right. So after I did that, it looks like B already finished, D already completed, E already completed in terms of crashing. We cannot crash anymore. The remaining A, C, and F. The remaining A, C, and F. Let's say, since they can be further reduced, why don't we go ahead into cycle number 4 here. Cycle number 4, I reduce 3 activity at the same time, because if I just simply select one of them, it is not going to work. A, C, and F. I crash activity A, C, and F. And how much is the cost? A, 5 days. 5 days for A, 500. C, basically more expensive. 6 times 5 will be 3,000. F will be 300 times 3, 1,500. So the direct cost for 3 of them would require about 5,000. But then the saving in terms of indirect cost is 250. The net increase is 47550. And then you add back with the previous value here, you are going to get a new project duration, which is 62,100 here. That is the thing. Okay, cycle number 4. So we managed to reduce further by 5 more days. But you notice that after we reduce 5 more days, A still can be reduced, C still can be reduced, and F still can be reduced. C still have 5 more days that can be reduced. Meaning to say, it is possible that we can go into cycle number 5. So cycle number 5, this I change into cycle number 5. Cycle number 5 is just I duplicate the same. I take everything from cycle number 4 because we are going to crash the same activity anyway by another 5 more days. So whatever data that we have from cycle number 4, we just simply duplicate, add back to the previous value. So we are going to get this amount. Okay, the amount is 66,850, and we are going to get the value, the project to be completed in 105, and it looks like C cannot be cannot be crashed anymore. The remaining A and F. I don't think A and F can be further reduced because it will not change anything. So meaning to say, after cycle number 5, what we get is basically we completely crash a project until it cannot be crashed anymore. But again, having said that, this is just an exercise. We normally do not do that even in the exam or whatever thing, because it will take a whole lot of time. I just want to show you that this is the possibility. If we want to crash the activity, we need to do it step by step so that we can get the data, and maybe the next step we are going to plot the data and then play around the concept of if we want to compress the project to whatever date or whatever days, we can know to what extent the cost increase would be. So at the end of the day, we can basically start discussing those kind of things to the client, etc., etc. Okay, then. Okay, that will be the slide, the end of the slide. The rest of the slide is just simply to test your understanding about, for instance, in the previous final exam, we asked about the direct cost loop. Well, again, if we are giving the data, the normal time and the crash time, crash cost and normal cost, so we can basically do the calculation of direct cost. So again, the direct cost is just simply this A and then let's say B. A divided by B. The differences between the crash cost and normal cost, and then you divide with the differences between normal time and crash times, and then you are going to get the value of crash, the cost slope. Okay, and normally in order to do the calculation, we need to have this kind of data so that we can construct the diagram. We know the normal duration, crash duration, normal cost, crash cost, etc., etc. And then if we split the cost between direct and indirect costs, so you must basically calculate the indirect cost. In order to know the indirect cost, you need to draw the diagram first, okay? Because we need to know the overall project duration. It is very similar to the one that our previous example anyway, okay? And another example, I see, decision has been made which only, if we want to make it simpler, selected activity only. But the way you approach this kind of question, it is not simply just looking at one activity per se. You must look at the activity in the network diagram, because you need to understand whatever changes you made in terms of the activity duration, it will influence the calculation, because all the activity are interrelated. Because some people do not understand the concept, they just simply crash one activity out of the context. So whatever it is, you must look at the activity in the network diagram. Then only you can understand how reduction of certain activity will influence the overall project duration and how much is the cost increase. Okay. All right, then that will be the class for today. Okay, let me close this thing first.